Today, we're going to talk about indigo. I hate indigo. It is the Jared Leto of colors. It is the worst part of everything that it's in, and it brings nothing to the experience. There's a lot more to this than what meets the eye initially. Prepare to learn more about this imposter primary color than you ever thought you'd need to know. Picture this: Sir Isaac Newton, the 17th century scientist, conducting his famous prism experiments. He sees red, orange, yellow, green, blue, and violet. But Newton loved ancient Greek philosophy and numerology. He admired the number 7, including its connection to the Greek deity Athena, the goddess of wisdom and war. This made him think that the number 7 was a wise, introspective number that needed to be applied to everything. Newton also idolized Homer, who consistently referenced the number 7 in his writings. In Homer's writings, you see the 7 appear many times, including 7 talents and 7 towns, and the list goes on and on. And it wasn't just Homer's writings that Newton wanted to connect to, he also wanted to connect to music, which is a beautiful idea. But you can't just shoehorn indigo into a spectrum. Color theory is not a boy band, it is science. So let's address some of the science about this. Humans, for the most part, have trichromatic eyes. This means we have cone cells in our retinas that are photoreceptors sensitive to different wavelengths of light. These cone cells respond to blue, take a huge gap, and then go through green and red. The green and red overlap quite a bit, which is why the most common color blindness is red-green. And in that gap between green and blue is, you guessed it, indigo. Finding its way outside of the normal responsivity of our cone cells, indigo struggles to find its place. You will have an easier time finding Waldo in this graph than you will finding indigo. In his book, Eyes on the Universe, Isaac Asimov wrote, "It is customary to list indigo as a color lying between blue and violet, but it has never seemed to me that indigo is worth the dignity of being considered a separate color. To my eyes, it seems merely blue." Asimov was a man of science and a keen observer of the world, and he clearly had strong feelings about indigo's place in the color spectrum. This quote reflects a broader debate about whether indigo truly deserves to be considered a separate color. And yes, I hate indigo so much that I bought a book specifically to show this quote. Our most common color models have already ousted indigo. We have the red, green, blue spectrum for digital displays, and cyan, magenta, yellow, key, or black for printed items. Indigo might find its way into the spectrum, but when it comes to actually displaying colors, we have clearly made a new set of primary colors, and indigo is nowhere to be found. Blue has worked hard to get where it's at. Throughout history, blue has been a highly valued color due to its scarcity. People were murdered over lapis lazuli, a deep blue stone. That stone has been mentioned in literature going all the way back to the ancient epic of Gilgamesh. The difficulty of recreating blue added to its value. Egyptian blue was one of the first known synthetic blues, but it required exact temperatures and exact measurements that were difficult to replicate. It wasn't until 1704 when Heinrich Diesbach created Berlin blue, which was a deep, intense blue, by mixing iron salts and potassium ferrocyanide. All this hard work went into synthesizing blue, and indigo thinks it can just hop on for the ride. It doesn't deserve it. It did not work for it. So let's talk about solutions. Enter the 6-color model, the model that we've actually always had until we decided to shoehorn a 7th into it. We got red, orange, yellow, green, blue, and violet. Red, yellow, and blue are the primary colors, while orange, green, and violet are secondary colors. By focusing on these 6 colors, we're able to concentrate on what really matters. This model isn't just a matter of aesthetics, it's about accuracy. Our eyes are most sensitive to these 6 colors, and by embracing the 6-color model, we're promoting scientific reasoning and truth in our understanding of color. The case against indigo is not only rooted in history and the limitations of human perception, but also in our modern understanding of color models. By challenging the traditional 7-color spectrum, and embracing the more accurate sixth color model, we can move past the indigo obsession and focus on a truer representation of the colors our eyes perceive. It is time to evict indigo, the freeloader of the color spectrum, and make way for a more scientifically accurate understanding of color. After all, who needs a imposter primary color taking up valuable space in our perception of the world?